Hey guys, welcome to another video. Today I'll be talking about magnetism in physics. So let's begin. Let's talk about magnets. There are two poles. These are called North Pole, South Pole. These two poles are always present in a magnet. No matter, even if you cut the magnet in half, there will always be two poles. Talk about the law of magnetism. For example here, these two are unlike poles. One is north and one is south. When unlike poles are present, they will attract. Like poles are present, they will repel each other. Differentiate magnetic materials into two types, soft and hard. The soft magnetic materials can be easily magnetized. They will lose their magnetism easily also. Hard magnetic materials are just the opposite. They are difficult to magnetize and they do not easily magnetized. They're also known as permanently magnetized. Let's make use of this example. Here, the diagram shows an iron core surrounded with wires that have current passing through them. When the current is passed through the iron core, for example, if there is a steel pin over here, it will be attracted towards it. But if no current is present, the steel pins will no longer be attracted. This is an example of soft magnetic materials. An example for hard magnetic materials are magnets. Let's talk about magnetic field lines. Firstly, what are field lines? This is an example of line. And if we have a magnet over here that has two poles, like I mentioned, north and south, this will always generate a magnetic field. If you try to take a magnet and place a magnetic material, for example steel or iron, close to it, it will get attracted towards a magnet. This is because it's present in the magnetic field. An example of a magnetic field. These lines represent magnetic field. Compressed, they are stronger magnetic field. There is a lot of space between each line. They are weaker. Note, the magnetic field lines always move from north to south. Touch each other. They cannot go like this. This is wrong. This is wrong. You cannot do that. They should always go like this, parallel to each other. This force of attraction, so magnetic field lines will touch each other, while here they will repel. I will draw another diagram here. If you have two north poles here, okay, two north poles here, north, south, south here, they'll always repel and go backwards. They'll never touch here. The point of X over here is where no magnetic field is present. Now let's talk about uniform magnetic field. Example, two poles over here. If I draw straight lines over here, the same distance between each line, from north to south, the same direction and the same length. This is called a uniform magnetic field because they have the same strength across. At any point, they have the same magnetic field strength. Being a magnetic material does not mean the material itself is a magnet. This means that if, for example, if I have a piece of iron over here, Fe, I represent it as Fe, doesn't mean it will generate its own magnetic field. This is wrong. It will be attracted if I place the Fe over here. It will be attracted towards the magnetic field. This is the meaning of magnetic materials. There are very few metals in the periodic table that are magnetic. This include iron, cobalt, and nickel. Please note the reason I mentioned steel is because steel is an alloy of iron. The thing about magnetic material is that no matter which pole, if I place Fe over here or Fe over here, it will still always get attracted. The poles don't matter to it. Permanent and induced magnetism. Permanent magnets always own magnetic field will be produced. Magnetism, when a magnetic material is placed in a magnetic field, the material can temporarily be turned into a magnet. This is called a induced magnet. For example, if I have a magnet over here and I place a magnetic material, is not correct. Why? Because these two poles are here, and if this is magnetic material, this will never be opposite poles. So this is wrong. It will always be north then south pole. Why? Because this is south and this is north, because when they both touch each other, they will become opposite poles, because opposite poles, like I mentioned over here, they always attract. All for today. I'll catch you in the next one.